Kia ora, Year 12. This video is just quickly going to go over questions 4 and 6 because I am trying to look after the dog and get out the door this morning. So here we go. Question 4 is one of these really boring but fiddly binomial expansions. So we have to expand this in ascending power of x, and this time we have to go up to and including the term in x cubed. Remember, you're given the formula for this. You just need to make sure before you start that you're in the right kind of pattern to do it. So we've got 1 plus 4x to the power of 2/3. So this is good. We've got a 1 plus here, and then we've got a block here. So that's going to be like my x in the formula, and this is going to be my n in the formula. So we can pretty much just get on with this one. So you can have your formula sheet with you, but you shouldn't need it at this stage of the year. So this equals 1 plus n times x, which here is our 4x. Right, then the next term, so we're going to need to do 2 more terms after that. 2/3 times n minus 1 divided by 2 factorial, which is just 2, times 4x squared. And then the third one, which I can just put over here, 2/3 times negative 1/3 times negative 4/3 times 4x cubed over 3 factorial, which I'll just write as 3 times 2. And now we just have to clean it up. Now that should be this. It's roughly equal to that because I've got a whole bunch of terms off the end that I've ignored, right? So this equals 1 plus 8/3 x, and go really carefully here. So we're going to have minus 2 over, so doing this bit first, just minus 2 over 18 times 16x squared plus, what have we got here? So I'm doing this by hand. I know some of you will be doing it with your calculator, but some of you are still making silly mistakes with these. So we've got plus 8 here from these ones, and then I've got divided by 27, 81 times 2, so that's, just leave it as 81 times 2, and here I've got 64x cubed. Right, so cleaning this up gives me 1 plus 8/3 x minus 16 over 9 x squared plus, let's see what we've got here. Well, we've got a 4 there, so 256 over 81 x cubed. Now let's just have a check of whether we can simplify that down. Well, no, we can't. That's as far as we can take it. So we're done. Okay, I reckon that was a very easy 4 marks, and most of you guys did that question really, really well. The next one that I'm going to do is question 6. I'm going to do this geometry one in a later video today when I've had a little bit more time and maybe a bit more coffee. So the first one here, this is a classic parametric question. We've got x and we've got y. So first, for 5 marks, we have to get dy by dx, and then we have to find the exact y coordinate of the stationary point on the curve. So notice that the first thing we're going to do for this is we're going to find t equals something, and then we have to chuck it back into the formula for y. Okay, so dx by dt is equal to 1 plus 1 over t plus 2, and dy by dt, we're going to have to use the product rule, so it's going to be t minus 1 times negative 2e to the negative 2t plus e to the negative 2t. Now, before I start putting those into dy by dx and using the chain rule, I'm going to clean them up. So here we're going to have t plus 2 plus 1. And here we're going to just take out, what am I going to do here? I'm going to take out a common factor of e to the negative 2t. And I'm going to expand this. So we've got negative 2t plus 2 plus 1, which gives me 3 minus 2t times e to the negative 2t. So dy by dx is equal to dy by dt over dx by dt, using horrible diagonal fraction signs, but that's how it's going to be. So we've got 3 minus 2t times e to the negative 2t over t plus 3 over t plus 2, and we have to simplify that. So we make that into t plus 2 times 3 minus 2t e to the negative 2t over t plus 3. So that's the first bit done. That's your first 5 marks. And that equals 0 for, well, we asked for a stationary point or a turning point? A stationary point. Stationary point. So equals 0 for a stationary point. So all I have to worry about is that top line. So we've got t, we need to solve t plus 2 times 3 minus 2t times e to the negative 2t equals 0. And so e to the negative 2t is always positive. And t must be greater than negative 2, right? We were told that at the start. And that's the case because the original question had a natural log in it, right? So we know that t can't be equal to negative 2. So the stationary point is going to come from 3 equals 2t, and t is equal to 3 over 2. Now, chucking that back into my formula for y, sorry, that's the alarm going off for something, right? So y is equal to, what have we got? Well, t minus 1, 3 over 2 minus 1 times e to the negative 2, what have I got? 3 over 2 times 2, giving us 1/2 e to the negative 3. And that's all there is to it. So more videos coming later on today. Thanks for watching. I'm thinking probably no one watched this one because these two questions were overall really, really well done.